Practice number 6, we're looking at the two proportion case. And so you see, again here, there's only one formula for the test statistic, and it's a z-score. Anytime you do a proportion based, it's always a z-score. No different here. Also, in that reading, you notice it's always independent groups. So it has a similarity more so to the test statistic for the independent groups. All right, let's take a look at practice number 6, and we'll make sense of all the pieces of that formula. It says, in a study on nursing home care, a researcher found that 12 out of 34 small nursing homes had an activities director employed at the home, while 17 out of 24 large nursing homes had an activities director. Well, that probably isn't surprising. Larger facility is going to have probably a bigger budget and probably more people. It's larger, so there's going to be more residents. So they're much more likely to have an activities director than a smaller place. All right, anyway, at alpha equals 0.05, test the claim that there is a difference in the proportion of the small and large nursing homes with an activities director. Okay, so it really seems like there is a difference, but obviously we got to go through and crunch the numbers. So let's investigate here. So they don't distinguish a group 1 and group 2, so we need to do that. I'm going to call group 1 the small nursing homes and group 2 the large nursing homes. The only reason I'm doing that is because they mentioned the small in the problem first, they mentioned the large second, and they give us the data for that second. So let's go with that. Okay, what does that mean for the null and alternative hypotheses? Here, the null hypothesis takes the same style as the other examples we've done. One big difference, though, it's not a mu anymore, it's a p, because we're talking about proportion of success. So the proportion of success for the first group minus the proportion of success for the second group, we assume there's no difference so that it will equal 0. For the alternative, we want to look really carefully at the way they phrase it. So test the claim, let me pull that down. Test the claim that there is a difference. So they don't say in the statement there, is it higher or lower? Just, is there a difference? So if we're just looking for a difference, then we need the not equal, right? Okay. Moving on to step 2. Now step 2, we're going to spend some time on because we have that new formula. Oh, looks like I got ahead of myself. With the not equal to, let's be really clear, we need to divide that alpha into the two portions, one in the upper, one in the lower, with 0 there, assuming that 0 is right at the center. Okay, we've seen this before a few times. So we started with 0.05, so we got to divide that in half. All right. Now, let's get into step 2. So let's start with this. We need to begin to find the test statistic. We need P1 hat and P2 hat. Well, they don't tell us these directly, but we can go back and get them pretty quick. So group 1 is the small nursing homes. So they said 12 out of 34 small nursing homes. Okay, so 12 out of 34. And let's go ahead and get the decimal for that. I'm going to round this to 3 places. I would recommend 3 is a good number or more. Okay, so the sample proportion of success for the small, and we need to do it for the large. How many large? 17 out of 24. 0.708. Okay, wow. Big difference between them. It's like double the chance, pretty much, if you're in a large place, a large nursing home versus a small. Is this going to be enough data? Well, that's pretty convincing right there. But let's see how it all plays out. Okay, when it comes to P and Q in the formula for the test statistic, you notice there was that sentence at the bottom. It says P is the total pooled proportion. So what do we mean by the total pooled proportion? It means look at all the successes divided by the total number of nursing homes. Just think of it all as one big group. So we had 12 here and 17 here and 34 there, 24. Put it all together as one, 29 out of 58. Turns out it's exactly 0.5. That's this worked out nicely. Okay. Well, if P is 0.5, oh yeah, I said that. Total successes, but think of it all as one big. Okay, we get it. If P is 0.5, then what is Q? Well, it's the complement. Turns out it's 0.5 as well. Okay, now we got it enough. Let's put it all in. Oh, we got N. Oh man, it keeps going. The sample sizes, N1 and N2, okay, 34, 24. We put it all into that big formula. Here we go. Sorry, just had to step away there, turn the light on. Getting a little dim. I think that's a little bit better. Okay, so we're putting everything in. Of course, we recognize we assume this part of the formula to be 0, the P1 minus P2. And all of our other numbers are in place. There, we've got this huge denominator, 0.5 times 0.5 over 34 plus 0.5 times 0.5 over 24. Big square root on that. Okay, take your time calculating that. You should get negative 2.66. Okay. There's our test statistic. It's a z-score, always a z-score for the proportion-based. So in step 3, we look at the p-value, the probability that capital Z and key moment here, do we have a less than or a greater than? Well, you may have picked up, hey, if this is negative, then it's a less than. Yep. Another way to realize that is right up here, that the first one was the smaller, so when we subtract, we get that negative answer. Or you might say, group 1 is less than group 2. So the less than. Okay. Going into your normal calculator now. And putting in less than that z-score. I think I rounded this to 4 places, 0.0039. Okay, so we're going to wrap it up. We compare our p-value. Be careful here to compare to alpha over 2, since we had to split that at the beginning. We're just looking at the difference. Okay, well, I don't think it would have mattered if we split it or not. That's the bigger one, right? And so if your significance level is bigger, you do have enough to reject the null hypothesis. And here it is, just in a sentence, and I was running out of space at the bottom of my page. There is enough evidence that there is a difference in the proportion of small and large nursing homes with an activities director. When it comes to phrasing this interpretation, I really just look at exactly the question that was asked. So they said test the claim that there is a difference in the proportion of the small and large nursing homes within, I just went ahead, there is evidence that, and it just copied that part. So there you go. That is two-sample hypothesis testing. You see the last part of the lecture is confidence intervals for two proportions. So I believe you get one homework question on that, but it might be even more helpful in your final project if you're looking at something like this. I will see you guys in the Zoom session. Good luck in homework.